All right, hey guys, so we're going to talk about law of sines. All right, we've previously learned how to solve a right triangle, but what if it's not a right triangle? Okay, so when we were solving right triangles, we were using Pythagorean theorem or trigonometry, so the SOHCAHTOA thing. All right, so something to know is that an oblique triangle is a non-right triangle, okay? Now, law of sines can only be used for angle, angle, side, or angle, side, angle, where the side is next to two angles or the side is between the two angles, okay? And sometimes we can use them for SSA triangles, okay? Now, the actual law of sines is sine of A over little a equals sine of B over little b equals sine of big C over little c. Sorry, that looks bad. And what I mean by that is that the sine of this angle is put over the one opposite it. The sine of this angle is over top of the side across from it. And the sine of this angle is over this side across from it, okay? Now, you don't always have to set all three of these equal to each other. It may be that you only have this information, so you set these two equal to each other, okay? Let's try some examples. All right, so find each missing measure, round each answer to the nearest tenth, so 1 decimal place. All right, so we have this angle here, which is across from x, so we do sine of 104 over x equals, and then we have this angle here, and it's across from 15, so we do sine of 47 over 15. All right, and if you don't remember, we have cross multiplying when we have proportions like this. So we end up having x times sine of 47 equals 15 times sine of 104. And then all we need to do is divide by sine of 47. And then we end up getting that x is 19.9 centimeters. Now, one thing I will say is make sure your calculator is in degrees. All right. So let's try number 3, and then I'll have you guys try numbers 2 and 4. All right. So we have this angle across from x, so we're going to do sine of 65 over x. And then we're going to have, sine of 92 over 11. So then if we cross multiply, we have x times sine of 92 equals 11 times sine of 65. And then you just divide by sine of 92. And you get that x equals 10, and then it's meters because our unit was meters. All right, so you guys try numbers 2 and 4. All right, so if you tried numbers 2 and 4 like you were supposed to, you should have gotten 19.4 feet for number 2, and then 8.7 yards for number 4. Okay, so then for number 5, okay, we have a pilot. He's beginning to travel. He travels 80 miles northwest, then he makes a turn, and then he returns to his original location. So this is his flight path. We're going to find the total distance of the flight. So well, let's call this x and this y. So we have, we have this angle right here. It appears that I've made a mistake on my own notes. Okay, so hold off on that question for just a bit, and let's actually just go to the back, and we'll talk about the ambiguous case, okay? So we have this thing called side-side angle, which is a bad word backwards, so it's helpful to remember that this is the ambiguous case, okay? When you have the side-side angle, sometimes it's possible to have one solution, two solutions, or no solutions, okay? This is called the ambiguous case because usually when we do math, we just get one answer, but this one is ambiguous because it could be one, two, or no solutions, all right? So to actually solve the ambiguous case when you're given side-side angle, okay, you construct the triangle based on the given information. Then you use the law of sines. Find the missing angle. All right, and then if you get a solution, subtract your solution from 180 degrees. And then Check your work because no two triangles can have two obtuse angles. All right? So let's try an example. So for number 1, I'm going to make this just a little bit bigger. Okay? So for number, 6. All right, we have a triangle. We're going to label it A, B, C. We know that A is 60 degrees. We know that AB is 30, and we know that BC is 27. All right? We're looking for angle X. So we have this angle across from 30, so we set it up as sine of X over 30 equals sine of 60, which is across from 27. All right? Now, if we multiply both sides by, let's do our cross multiplication first. And then we divide by 27. All right? We end up getting that sine of X equals 0.9623. Now, remember, to separate sine from its angle, you have to do the inverse sine of each side. And don't forget on your calculator, that's second, and then you type sine. Okay? So you do the inverse sine of each one. So then you get that X equals 74.2 degrees. Now, here's the thing though. We use law of sines, then we need to figure out, okay, well, if this angle is 74.2, it's also possible that whatever 180 minus 74.2 is, could be our other answer, which would be 105.8. Well, I wrote that wrong. Hold on, sorry. That should be 105. Okay, so 105.8 degrees. But then we need to check, so I'm going to leave some room over here. If I do 60 plus 74.2, that is less than 180, which is good because in order to have a triangle, I have to have 3 angles that add up to 180. So if my 2 angles are less than 180, that means that I could find a third angle that would work for the triangle. So that works. All right, if I do 60 plus 105.8, it is also less than 180. So that works as well. Okay. All right. Let's try number 7. So we have another triangle. Okay, so we have A, B, C. We have 89 degrees here. We have AC is 34, and we have AB is 26. All right. So then we are looking for angle B. So we set it up as sine of X over 34 equals sine of 89 over 26. So we can get 26 sine of X equals 34 sine of 89. Divide by 26 on both sides. And we get sine of X equals 1.3075, and that's a point, sorry. If we do the inverse sine of both sides, we end up getting that X is, and it should have popped up with an error on your calculator if you do inverse sine of this number, which means that this would be no solution. Okay? All right, now I want to do number 8 together, and then I'm going to have you guys do 9, 10, and 11. All right, so number 9, we have another triangle. We have A, B, C. We have C is 102. Obviously, this is not drawn to scale. AC is 21, AB is 24, and we're looking for X. So we have sine of X over its opposite side, so 21, equals sine of 102 over its opposite side, which is 24. All right, so if we solve this out by cross multiplying, we get 24 times sine of X equals 21 times sine of 102. Then we divide by 24 on both sides. So then we get sine of X equals 58.9. But we need to check and see if we can do 180 minus 58.9. And we can, and it gives us 121.1. So we could also have 121.1 degrees. But then we need to check. So 102 is already the angle that we know is for sure in this triangle. If we did 102 plus 58.9, that would still be less than 180, meaning we could find a third angle to make the triangle. So that works, okay? If we do 102 plus 121.1, that's